Hello, this is Dr. Hooper bringing to you the second in our series of webinars. This one is titled Be Your Own Advocate for Environmental Assessment. This is part one of 3 parts. This one is titled Mycotoxins and Fungal Infestation in the Indoor Environment. The first question we always ask is what is a fungi or mold? It's a kingdom of the eukaryotic organisms, which is where human cells fit as well. They don't have chlorophyll, but they do have cells that are bound by rigid walls. None of these conduct photosynthesis. The examples that we see that we know of are mushrooms, fungus, and mold. They absorb food in solution directly through their cell walls and reproduce through spores, which you see in this picture, these little balls coming off of this flower-shaped organism. The mold, a general term that's used for fungi, so fungi/mold are used synonymously. They generally refer to a visible colony of fungi growing in an indoor environment. Mildew is a layperson's term, like my grandma used, to refer to mold growing in the house, or usually in a bathroom or something where they grow on fabrics and wood. The chemical agents that are produced by molds are called mycotoxins, and these are used for chemical defense systems of the fungi or mold, and they cause, if we get involved with them, they cause human disease and or acute and chronic effects. The mycotoxins that we're very interested in are aflatoxins, trichothecenes, ochratoxins, and citrinin, and hundreds of others. But there's only about 10 to 12 that really are concerning to us. The trichothecenes that we notice are they inhibit protein synthesis, so they stop all the protein synthesis going on in the cells. They can cause anemia, and it has been noted that they can cause a pulmonary hemorrhage or blood coming from the lungs. Ochratoxins and citrotoxins or citrinin can cause nephropathy and immunosuppression. Aflatoxins are hepatotoxins or liver toxins, and they are carcinogenic, or they produce carcinogens. The glucans are cell wall components, and the volatile organic compounds that they produce are very irritating to skin, eyes, and organs. Mycotoxins are the substances that are produced from the fungi and are referred to as toxigenic fungi. These are Aspergillus, Fusarium, Penicillin, Stachybotrys, Myrothecium, and they are the ones that produce the mycotoxins that we're most concerned with. Fungi that produce potent mycotoxins are seldom abundant in an outdoor environment because the wind is blowing them all over, and they also are most toxic when there's toxic exposures in the indoor growth of fungi. Mycotoxins are low molecular weight substances. They're very low. They can grow, not grow, but they are produced, and then they can attach to dust. They're produced as secondary metabolites, or only if they're needed. That's why they're called secondary. There's 300 to 400 of these recognized as mycotoxins, but we only are concerned with 10 to 12. Some labs think they're looking at more, but we look at the different components of these. Like aflatoxin is the family, and we look at the 4 kids that are involved, B1, B2, G1, G2, which we'll get into in another series. Most of the literature that we read inhibits or attributes mycotoxins to ingestion of foods which are contaminated, but the airborne contamination is a problem as well and cannot be ignored. The mycotoxins, as you can see here, are structures that are very similar to hormones, progesterone, estrogen, and thus they can cause a lot of problems with female hormones and male hormones. The route of exposure of mycotoxins, as I noted before, are associated with eating food or drinking contaminated toxins. We can breathe in moldy air in the damp indoor areas, and we have dermal absorption. Here's a picture of mold growing in a wooden headboard in a room with high humidity. And in this area is a light white or discolored area of the headboard, and that's due to the mold growing in the headboard. The diseases associated with mycotoxins are the climate changes that many believe can increase exposure to mycotoxins. It's because it's dry. They're looking for water, and they've taken their spores and consolidated them down to make sure there's good DNA protection. The extreme precipitation from storms and floods can cause moist conditions, and they just love that. Or you can have a drought where that weakens the seed kernels of plants, and so then the mold likes to get in there and can contaminate it, but most importantly, it grows and produces the toxins. So there's increased temperatures can also promote fungal growth. Aflatoxins are expected to become more prevalent as climate continues to change. Here's a graph that shows how the aflatoxins are gradually, as if they're looking for them, have increased over the years, over the past 100 years, and they believe that they're going to become even more prevalent as the climate continues to change. Young children are among the most vulnerable. However, the elderly, immune-suppressed, cancer or transplant patients, diabetics, are also very vulnerable. The children are very, very vulnerable because they're different. They have a short stature, they breathe closer to the ground, they have ongoing lung developments, and they have increased air intake because they run around all the time. Indoor mold growth is very important for us to understand. The sequence of events usually are due to water intrusion or water damage. The substrates for mold growth are cellulose, which are plant-based material, wood, paper, wallpaper, drywall, ceiling tiles, carpet, glue, dust, anything that has cellulose in it. Mold growth starts and continues as long as adequate moisture is present. And the production of spores and secondary metabolites can be released. They get on the dust and we breathe them in. Therefore, we get these mycotoxins. We can get VOCs, or volatile organic compounds, and we can cause respiratory distress as well as any other disorders that we've talked about and we'll talk about further in the future. In 1982, the World Health Organization coined the term SBS, which is sick building syndrome, for people who are in a building with water damage and mold growth that became sick. And all these functions are associated with the mold contamination. And you can see that sore throat, ear infections, pneumonia, which is common among all of us, also are associated with mold and mycotoxins. So is air sampling for mold necessary? Well, NIOSH, who's the government arm of looking for things at occupational hazards, does not recommend routine air sampling for mold in damp buildings. Now, they put out this alert because air concentrations of mold or spores cannot be interpreted with regard to health risks. They don't know what to do with these. As you may have known or may have heard when you go to doctors, nobody seems to know, and they're going by what the government says. Instead, NIOSH encourages detection by thorough visual inspection and detection because it smells musty or moldy. Well, mycotoxins don't smell. It's the organisms that smell, and I don't know of one mycotoxin that has an odor to it. So take this for what it's worth, but if you suspect you have molds and mycotoxins, you should have them tested. We're going to talk about that in the next two of this series. So the questions that you may have, you can email them to me at dhooper@realtimelab, or you can look up under our Twitter account, our Facebook account, or you can look on our website. Now this concludes the first of a series of 3 for environmental contamination webinars. Thank you.